Howdy everybody, this is Jill Garcia coming to you from the UTGCD Virtual Education Lab. I'm going to be giving you guys an audio tour of our groundwater education mobile today, and hopefully you're going to walk away with a better understanding of how groundwaters work, how aquifers operate, and how you can be more water conscious in Texas. We're also going to do our very best today to make sure our cameras capture all aspects of the groundwater cycle. But if they don't, shoot me an email at the end of this presentation and I'll send you some high-definition photographs. We're going to be walking through the water cycle and humans' impact on the environment. So we'll make sure to define some terms and then we'll go ahead and get started. See you soon. The first phase of the water cycle is precipitation. Water can be absorbed by plants, run off to nearby lakes and streams, or infiltrate to become a part of groundwater. Depending on the severity of the rainstorm, sometimes soil and shrubs can become agitated. This potentially allows for erosion and weathering to take hold, and which is why it is so important to incorporate native plants into your landscape. Do you see those clear straw-like structures? We're going to talk about them more in just a second, as those represent water wells. We're going to investigate what happens to groundwater when people start to use it. We are now observing aquifer recharge, which is the process of replenishing an aquifer's water volume. As an aquifer recharges, its saturated zone increases, and the water table will often rise. Can you see that happening in the video above? This is crucial for water well users, as if they fall below the water table, their water well will typically run dry. Let's go ahead and see what happens when we pump water out. Notice that as soon as water is pulled out of an unconfined aquifer, the water table immediately drops. Do you see that line connecting the water wells? This is a great example of why we need to take care so our aquifers don't become depleted. Note that groundwater pumping is adversely affecting the water volumes of surface level streams and lakes. This is due to extensive interactions between surface water and groundwater. If a water well ever falls below the water table, what do you think that means for the user? When the water table lowers as the result of pumping in an area, that's referred to as drawdown. Depending on whether your aquifer is confined or not, overusage can drain an aquifer quickly, especially in the summer months. Drawdown can be either regional or localized. Now it's time to talk about pollution. There are two major kinds in our model, non-point and point. Non-point pollution means that the contamination is happening from a variety of sources, typically runoff from a farm or fertilizers. Let's see if you can find the runoff contamination within our model. It might take a second, but hopefully you're noticing the dark blue splotches on the right-hand side of the model. The density of the contaminant usually determines where it goes in the aquifer. Lighter density contaminants will spread up towards the top, while lower level density contaminants will make their way towards the bottom of an aquifer. It's all our responsibility to make sure this doesn't happen very often. Sometimes latent contamination can sit in lakes and rivers for decades, and oftentimes will be passed along to biological organisms, such as fish and amphibians. The sped-up path of a contamination plume moving through the Upper Trinity Aquifer. Notice that that path is strongly influenced by the local geology, and any rock formations with high porosity or permeability can act as superhighways for the contamination. Water wells can also transmit pollutants as well, which is why our office regulates the plugging of abandoned wells. Hopefully you've enjoyed this brief refresher on the Upper Trinity Aquifer. If you're interested in more games, activities, information, or ways you can get involved in water conservation in North Texas, visit our website at uppertrinitygcd.com.